Pre-algebra, lesson 44, roots, order of operations with exponents, and roots. So let's start with roots first. So roots are like the inverse operation of exponents. We can see that really clearly here in our example, where we see 2 to the power of 4 is equal to 16, and the fourth root of 16 is actually the number 2. All right, so they're inverse operations in that they do the opposite of each other, the same way that multiplication and division do the opposite of each other. Another quick example would be to say that 2 squared is equal to 4, and the square root of 4 is 2. Okay, now let's go to some examples. Let's see how we can solve our roots. Now, one of the best ways that we can solve our roots, as opposed to memorization, is using what's called the factoring method. All right. Now, well, you're going to notice some different things. Like here we have a square root, here we have a fourth root, here we have a cubed root, and etc. Or the third root is another way to say it. Now, whenever there's no number in this little crook of the radical symbol, that number is assumed to be the number 2. So if there's ever no number here, it's always a square root, and it's always a number 2. Now, the reason why that matters is because the number that's in this little arm, or this little crook, is going to tell us how many, what size group we need in order to create whole numbers. So what happens with roots is you can regroup these numbers to create whole numbers by using factor methods or factor trees. So for example, right here, this 16, I can factor into the numbers, let's see here, 4 times 4. And what I've done here is now I've got the same number 2 times, which satisfies the 2 requirement in that arm. So it's 2 of the same number, not the number 2, but 2 of the same number. I have 2 of the same number, so I've created a group. For every group you create, that makes one whole number. So since I have one group of 4, that makes one whole number 4, which means the square root of 16 is 4. Okay? So essentially the way that we think about this is here's a radical, and I've got the number 16 trapped under the radical. If I can satisfy a group of 2, then for every group of 2 I create, one whole number can escape. And if I can get all the numbers to escape, then the radical goes away entirely. Now let's look at this with the fourth root of 16. So now that the number in the arm is 4, I have to find 4 of the same number. So let's start factoring 16. Well, I can go into 4 times 4, but I've only got 2 numbers. So let's keep factoring. 4 will be 2 times 2, and this 4 will also be 2 times 2. Now I can see I have a single group of 4 2's. So for one group of 4, I create one whole number 2, which is the fourth root of 16. That's the answer. Now, let's do the same thing moving on over here. So we're just going to do a couple more examples so we can kind of get the hang of this. Here I've got the cubed root of 27, which means I have to get the same number 3 times. So let's factor 27. I get 3 and 9. 9 is a prime, so I can't factor 3 anymore. Oh, did I say 9 is prime? 3 is a prime, so I can't factor that anymore, but 9 isn't. 9 will become 3 times 3, and I'm done factoring, so now I look for groups, and I've got 1, 2, 3. I've got a group of 3 numbers, and that group makes one whole number 3. So my answer is 3. That's the cubed root of 27. Last one. Now, you won't always have your factors work nicely, and sometimes you have more than one number group. So let's do this. Let's find the square root of 36. So I can divide 36 by 3 because I know 3 times 12 equals 36. Okay, and then 12 is going to be 2 and 6. Okay, and then 6 will be 2 and 3. Now something interesting happened here. I'm done factoring, and I just need to get groups of 2. Now I've got a group of 2 numbers here. That gives me one whole number 2, but then I also have extra numbers at the end of the stems. Well, these 3's also make a group. They make a pair of whole numbers, which means I also have a whole number 3. Now whenever you group out more than one number, what happens is you take these 2 numbers and you multiply them. So I'll just take 2 times 3, which gives me an answer of 6. And we should know from memorization that 6 is the square root of 36. So whenever you're grouping, if you get more than one whole number, you just multiply all the numbers you have. All right? Now there's one special case we need to look at while we're doing these, and that's the number 1. Interesting thing about the number 1 is that if we take 1 to the power of 6, which is equal to 1 times 1 times 1 times 1 times 1 times 1, the answer will just be 1. So that means the root of the number 1, it doesn't matter what the requirement is, if it's 5, 6, 7, 2, 3, if it's a square root, a cubed root, a fourth root, it doesn't matter. The root of the number 1 will always be equal to 1 because this 1 can factor into 1 times 1, which can factor into 1 times 1, which can factor into 1 times 1, which would factor into 1 and 1. That would give me 5 1s. So I can always create the required number using the number 1 because the nature of 1 to the exponent. So the root of the number 1, no matter what the number is, will always be 1. Now, let's go on to the second half of the lesson, which is how do I use exponents in the order of operations. If we remember our order of operations, we know the rhyme, please excuse my dear Aunt Sandra, right? And we have to deal with parentheses, exponents, multiplication, division, addition, subtraction, right? I draw the arrows under multiplication, division, and addition, subtraction because they're equals and we solve them from left to right. Parentheses first, exponents second, okay? Now, we're using all pieces of PEMDAS now when we're doing our order of operation problems. So that means we need to start solving them a different way than what we used to. Many of you might be used to just solving it piece by piece as you go down the problem. But now that we're using all letters, it helps to only solve one piece at a time and rewrite the problem as we solve one piece at a time. What I mean by this is I'm going to start off by solving the parentheses, right? I'm only going to solve the parentheses, and I'll rewrite everything I get once I solve the parentheses. So I only see one set of parentheses right here. I have 3 minus 2 plus 8. 3 minus 2 is 1. So that's 1. Plus 8 is 9. So in order to make the parentheses go away, I know that's going to end up becoming 4 times 9 because this 4 is right next to the parentheses. So that parentheses goes away, this becomes 9, and these are being multiplied because the 4 is touching the parentheses. Okay? From there, I'm just going to recopy the rest of the problem. I'm not going to change anything else because I'm only doing one step at a time. This may seem very tedious for some of you, and you won't want to rewrite all of this. It's to your benefit, and it's worth the extra step because you make less errors this way. So now that I've solved all the parentheses, that can go away. Next, I'm going to solve all the exponents, right? That's the second step. So I'm only going to solve these two numbers right here. And yes, roots count as exponents, okay? So exponents and roots, those both count as e in the exponent step. So 2 squared is going to become 4. I'll put the plus sign right in front of it. I'll put the minus sign, the cubed root of 27. I might need to work that off to the side. So if I do the cubed root of 27, that will become 3 and 9. 9 will become 3 and 3. Got a group of 3's, so that just equals one whole number 3. So I go back over here. That's whole number 3. And then I'm going to copy everything else that didn't change. So 4 times 9 plus 4 minus 3 plus 12 divided by 2. Now I'm on to the multiplication and division step. So I'll do that in orange. So all I'm going to do is multiply and divide. So I have 4 times 9, that gives me 36. I'll recopy the plus 4, copy the minus 3. 12 divided by 2, I have to solve that. That is also, that's going to be 6. So I put plus 6 at the end. Now I go to the final step being the addition and subtraction. We'll do that in purple. All right. So now 34, and I again solve it from left to right. 36 plus 4 is 40. 40 minus 3 is 37. 37 plus 6 gives me, let's see here, 1, 2, 3, 43. 43 is the final answer. All right. So that's how we do our order of operations problems now. Just do them line by line, going 1, 2, 3, 4 steps at a time. Okay? It's a little bit extra writing, it's a little bit extra work, but you will not get it wrong if you pay attention and you solve them this way. If you have any questions, let me know on the school website, and I will see you in the next video.